Okay, I think it has started. Let me share my screen. Okay, the first item on the agenda, Mukund, I see that you're here today.
Yeah.
Go ahead and click this.
Hello everyone. I have Nabil here as well. So we work on setting up queue for our training and inference clusters. We have a presentation made as well, just to give a high-level walkthrough of what the issue is, what the proposal is, and we can
Oh,
get some
cool.
going on from there. Just give me a second, and we'll share the presentation. I can check.
Thank you, co-host. Confirm. Okay, I think you could share now.
Actually, can you make Nabil?
Oh, yeah, yeah. I hit allow. Did that work?
Checking 1 second. Oh,
Oh, let me make Nabil co-host. Okay, there we go. I think if you're talking, we can't hear you. There we go.
sorry.
Yeah.
Is it better now? Okay, perfect. Cool. So thank you, everyone. So we'll be presenting the CAP that Mukund had opened some time ago. In the first bit, we'll be going through the challenges. The second bit will be around what we are proposing for a solution. So let me go through it. So this is an example of how a multi-queue setup would look like. So generally, there will be some cluster queue on the manager cluster with the full quota of the 3 different worker clusters, and it will be dispatching to all of the workers. In our example, we have 3 teams. Each team has their own quota. Given another approach that we could have taken is setting the quotas on the manager cluster. However, that it has its own caveats as well. We will be showing them in the next slide. But in general, in this flow, as you all know, multi-queue, you get a workload, it will be dispatched to all worker clusters, whichever admits it first, based on the quotas for each CQ. So ideally, for team 1, if it submitted something to cluster 2 or 3 or 1, depending on how much quota it's actually using in each one. Yeah. For the next one. So the pain points we have been observing while working with multi-queue is that the preemptions on the manager doesn't really respect clusters or task boundaries. What that means is, so in our original setup, we had all the teams on the manager cluster, but what we found out is that manager cluster, when it gets a workload and it's fully occupied right now, so it starts to preempt. So it might end up preempting from team 1, for example, but some workloads will be preempted from cluster 1, other workloads will be preempted from cluster 2. So we end up with some fragmentation where the new incoming workload wouldn't be able to be dispatched without needing to preempt even more workloads to get the needed capacity to run on any of the workers. So that was the first problem. So there is basically no respect for the cluster or topology boundaries in that sense. Even in that case, so assuming everything is working and it's preempting from the right cluster, the other layer of topology, it wouldn't necessarily be preempting from the same topology. So in that case, if we have multiple node pools in the same worker cluster, each node pool will, if you are going to be preempting from something, it needs to be from the same node pool. So it doesn't take any of that into consideration. The next bit is that workers make decisions in isolation. Decisions here mainly is around preemptions. So the example that we also saw is that the manager, initially when the manager was making decisions, we ended up with that problem. However, we removed the cluster queues from that layer. So now it's more on the workers to figure out what's happening. And we ended up with another problem where we might be preempting high priority jobs while there are still low priority jobs running. So, and it's not, that's not the expected behavior from our perspective. Ideally, it needs to be more consistent of preempting lower jobs first, then so on and so forth. And that's not possible given that each worker doesn't see the full picture. Each worker only sees its own world. Same thing for DRS, because each worker is in its own isolation. So one team or one cluster queue might be borrowing on one worker while it's lending on the other worker. So the net of all of this, it might still be under its quota, and on the worker that it's borrowing on, it might end up being preempted while it's still under its own quota. Because again, same problem. Worker is only working in isolation, and if we started moving these quotas or the setup into the higher ups on the manager cluster, it starts making decisions that isn't consistent with the lower layers. Yeah, so on the operational complexity side of things, as I mentioned, now what we are the fix that the hacky workaround that we reached is that we set high quotas on the manager cluster, so it doesn't make any preemption decisions. And now we are also faced with the issue that we need to fragment quotas, so that, for example, team one, ideally, we would love to give it something like 30% of our full capacity. However, we end up basically breaking it down by clusters so that it makes reasonable sense of how it might work. However, that's not optimal at all. So that's one thing. The other thing is that one of the features that we are keen to have is basically seeing what's the position of a given workload in the queue. Usually we do this by sorting the workloads by priority, then by timestamp of their submission. However, because every worker has its own logic, it's really hard to build a full picture priority queue to see what's actually or who's going to be going in next. That's also another caveat. And lastly, with the rolling upgrades, moving capacity. So if we want to upgrade one cluster or changing or fixing or upgrading one of the node pools, moving capacity from one node pool to the other becomes a challenge, because now we need to change the quotas of all of the teams so that they start ignoring this node pool and accommodate for the other node pool. So it's an operational overhead basically. And yeah, so for the goals.
Yeah, any questions till now? Or are we using multi-queue differently? Is there any hacks around using the current setup to solve some of the problems that we've seen already? Anyone has any suggestions there?
I'll wait until the end. I mainly have something around, like I haven't gotten a chance to like commenting yet. It's mainly around the cap itself. But great presentation so far.
Cool. Yeah, so the goal, the ideal setup that we would like to see is to have a central definition of quota for all the teams just in the manager cluster. So that way we can easily define, let's say we have 100% of the nodes, we can easily define, okay, 30% of the nodes go to team one, 40% of the nodes go to team two, and so on, so that it's all managed in one place. We don't have to worry about managing the quotas in all the different worker clusters. And in each of the worker cluster, we just define the whole capacity that the cluster can take. So this simplifies the quota management for all the different teams, especially when we have also thought about giving quotas for projects. Each team can have multiple projects. So team one can have 4 projects, team two can have 5 projects. So we would end up managing like 10 to 20 different cluster queues when it gets exceptionally hard if you have to distribute that quota across multiple worker clusters. So this is on simplified management of quotas for different cluster queues. And what we would also like to see is global fair sharing. So we don't really care so much where team one's workload lands, right? It can land in worker one, it can land in worker cluster two, etc. But there are certain nuances there where certain workloads might prefer one region over the other. So we might want those features as well. But at a high level, we don't really care so much as to which cluster the workload lands, but what we care mostly about is a global fair sharing that, okay, team one has a DRS of a certain value across all the different clusters, and we identify the highest DRS CQ across all the different workers and preempt that workload. This gives us fair sharing, not just at the worker cluster level, but at a global level across all the different clusters. And what this allows us is to also access compute much more easily. So I don't have to worry about defining, okay, cluster one, team one has X quota, right? So if we go away from that, then any team can access compute capacity in any cluster. That also reduces the chances of a team's workload from getting preempted, while it need not have been, if we considered the global quota. Yeah, next slide. Yeah, so one of the proposals, so this is the KEP that I shared, is to extend the current task system that we have, the topology of our scheduling feature that we have within queue, but extend this to multi-queue, where we consider each worker cluster as its own topology level. So here I propose level one being a topology cluster. So each cluster gets its own level. And in addition to that, all the other worker clusters can have their own levels. But here, for simplicity, I've assumed that all the worker clusters have the exact same topology, which need not be true, which is usually not true as well. But for the sake of simplicity, let's assume that all the different worker clusters, we are able to get them within a single topological level order. And if you're able to do that, this allows us to define all of the LQs, CQs, resource flavor, and all of that in a single location in the manager cluster. And worker clusters can, sorry, can I access?
Yeah. Sorry.
Yeah, then worker clusters can just define the whole quota that's available. And manager cluster can make decisions which respect the task boundary and also the cluster boundary, right? Because assuming we set all the task levels to be required and use the preferred, both the required and preferred task configuration in the workloads, then we get the right preemptions, global preemptions, right ordering, DRS across all the clusters for free. So yeah, so this is just explaining what we get. So we make cluster the top task level. Manager cluster knows topology of all the clusters. Manager cluster makes all the admission preemption decisions. All the quotas are defined only in the manager cluster. So advantages are, I made a quick prototype with the help of an agent. It seems fairly small. The number of changes was just 300 lines, really small surface area. It seems quick to implement. Simple operational setup in that all the CQ is in one place, and all the features that we have with tasks in a single cluster, we automatically get in a multi-cluster setup as well. Again, this is with a very limited prototype that I've made, which I did really quickly. But the downsides were immediately highlighted in the KEP by multiple people. So one is it doesn't work well with auto-scaling clusters. It forces tasks where it's not required. So not all the use cases of multi-queue need tasks, right? So, but we are unnecessarily forcing tasks and all the other constraints that come with it. And it also means that we need to watch nodes and pods across all the worker clusters in one central manager cluster, which may not really scale, but I haven't really tested it. But there may be ways around it, but this is definitely a downside to think about. And it has other assumptions as well, where we assume the topology is same across all the different worker clusters. There are so many other nuances to consider, and it may very well not work in a general case. Yes, Amy?
You can finish first and then we can start questions.
Yeah, so this is the first proposal, this the high level, but next I have an alternative which we can discuss as well. But any comments on this? Happy to talk through about that now.
Yeah. At first I just want to say that this global fair sharing need is like a common need across like a lot of customers that I've seen or like users. So I do think that the problem needs to be solved. It's more of like the nitty-gritty of like how.
Yeah,
I do have a concern around like the needs to watch nodes and pods across all clusters. I wonder if there's a way where you can flip it instead, where it's like at the global level, you allow that to handle fair sharing, right? Like you don't need TAS for that yet. And
yeah,
then have a way for the children cluster to actually publish like a ledger. Because we already sync workloads to multi-queue, which each workload already has topological assignments. And so you can like bubble that, you can like plumb that in. I'm not sure if it's already there or not. But then the only remaining thing is you just sort of need to like publish the remaining capacity that's free. Um, but just some food for thought. But I think it's just like implementation details where like the ultimate need is like for like we for sure need to solve this. Yeah.
yeah. Maybe
Um,
I'll walk through the second alternative as well, and after that, I can take the questions because that may answer some of the questions that you may already have. And this also
yeah.
touches upon the point that Amy mentioned, where instead of manager having to have all the information, can we outsource some of the decision making to the worker clusters? But so this is one alternative where manager selects all the probable fair share victims, and it sends the list to the worker, and the workers try to do a real placement and feasibility plan. So yeah, so everything that they do right now, right? So is the task possible? What other workloads can be preempted, etc. And we get the response back, and the manager can then decide uh, based on the response it gets from the worker, which worker to choose based on preemption costs and other decisions as well. So this is the alternative I was considering. Maybe it's similar to what Amy was mentioning. But maybe, yeah, Oleg, do you want to go next?
Thank you. Mm, I'd like to ask, ultimately, would you like this to be another mode in multi-queue available alongside the current mode, or would you like this to replace how multi-queue currently behaves?
I mean, ideally, I think this would be the default expectation. At least this was the default expectation for us on how multi-queue would work. So if this is the default, that would be great. But as we explore this option, we can very well have this as something that you enable if you want, and in the future we can consider making this the default. So I don't mind this being a separate system during the transition period.
Okay, the reason why I'm asking is that intuitively, this looks sweet. Yes, this looks a sweet user experience for anyone who can afford in terms of scalability. But I
Yeah,
think we needed not to be the only one due to scalability exactly. And it's not even, just due to watching nodes and pods, which was mentioned here, but even more fundamentally, we have seen customers for whom, just running scheduling cycles on a single cluster for all the workloads they have is too slow.
yeah,
And as far as I know, multi-queue, one of ideas behind this, behind multi-queue, was that in such cases, when scheduling is too slow, we should try to distribute the heavy work of scheduling logic, which means that by design, the manager cluster should be only a rough dispatcher which doesn't know too much and doesn't think too much. Because if it was to think too much, it wouldn't cope with all that work. And
yeah,
then for such heavy traffic cases, unfortunately, your proposal goes against what we wish, or at least in the other direction of resolving the trade-off. So I think my sweet spot would be to have both these modes available permanently. Of course, that has downsides on its own. Yes, maybe even yours could be the default one if most customers have smaller loads
yeah,
that
yeah,
allows it. Yeah, but I'm feeling it's essential to retain the old way as well.
yeah. Yeah, that definitely makes sense. I mean, even for us, we have multiple different types of use cases, and in one of the use cases, we do have hundreds of thousands of workloads that we need to run across multiple workers, and it may very well not. The proposal may very well not scale even for our own use case. Um, but Yeah, I agree that we may want to maintain the two different modes even for the long term. I agree. Cool. Yuki?
Yeah. So first of all, so thank you for sharing this interesting functionality. So honestly, so I have same concern about OLEG and other one, like so performance and scalability issue. So I don't repeat again. Um so I just wondering if so did you check about the Gora automation functionality, which can allow us to sync the worker cluster nominal Gora to the management cluster queue Gora?
Yeah, but that won't work, right? Because what quota automation does is basically sums the quota for all the different workers and sets it in the manager. Is that right?
I don't think so.
Essentially, yes.
Yeah,
Go
so
ahead, Oleg.
Essentially, it does that. Yeah, it checks the quota defined on the workers, sums them up together, and sets it as a quota on the manager. So I understand that plenty of problems that Mukund mentioned, yes, including some unfortunate fragmentation, unfortunate or suboptimal choice of preemption targets, lack of global fair sharing, and so on. Plenty of these problems remain unresolved just by the global quota automation feature. And that is by design, because quota automation feature was designed with this mindset, behind that we should keep the manager not too smart, because a too smart manager would not scale. And here we have this exactly opposite direction. Let's make the manager very smart. It won't work when it won't scale. But on the other hand, as long as it scales, it will offer a great UX to the customer. And I see the benefits of that.
Also,
Just a different path.
Kevin made a good point where we have a pretty packed agenda. So let's kind of wrap this up really quickly. Andrew, do you have a quick question as well?
Sorry interrupting. So actually, so we also mentioned about dynamic quota autoscaler. So we are currently planning to implement auto synchronization mechanism across worker cluster and manager clusters, and this discovery plugin can be implemented by other controllers or whatever. So I'm wondering if this functionality might be conflicted with the next TQO features. So I just want to ask about that.
Yeah, I don't think they are against. I think they're complementary. So dynamic quota orchestration. So it's just trying to identify which cluster has how many nodes available, right? And it tries to support auto scaling clusters. But that's not really the problem, right? So the problem is global fair sharing. So if I have to summarize this challenge, it's global sharing. So the manager has to know all the different possibilities of all the different worker clusters and identify what is the best preemption decision that we have to make, which is globally optimal. So that's the challenge right now. So currently, all the decisions around preemptions and placement are local to a worker. But what we are after is a globally optimal preemption decision and placement, which I don't think the dynamic code orchestration issue addresses, if I'm not.
So in my philosophy, so I was wondering, just wondering, so schedule multi-cluster scheduling was responsible by dispatcher, multi-queue dispatcher, and the quota management will be managed by DQ or quota autoscaler. So I was just confusing about how can we integrate this feature to other functionalities? Yeah, just comments. So yeah, today we don't have enough time, so we can.
Yeah. Also, I just wanted to start this discussion. We definitely can't have a solution for this now.
Yeah.
To start this discussion so that we can continue it offline. But yeah, thanks for the opportunity. And maybe Andrew, quickly, if we can take your question as well.
Yeah, I don't think I'm gonna add a lot to what the guys already said, but I was talking about the dynamic quota orchestration already, how it's going to work with this approach, and what about the network load between clusters? Because if you have thousands of clusters, it's like, did you guys try to do any network analysis or anything, how it will look like, all these things? Because like Oleg said, it's going to be a lot on the MQ manager, and also think about how it's going to integrate with something like WAS, workload aware scheduling. If we only do everything on the manager cluster, then this manager is going to be a single point of failure. So yeah, something to also think about.
We have not thought about that as much. Like I said, we are starting to think about this, and I wanted all of us in this meeting to start thinking about this as well, if it's an important enough problem. So just wanted to start this discussion. But yeah, thanks again for the opportunity.
Thanks so much for presenting. Yeah, it was really great. But yeah, let's take this conversation offline, maybe on Slack, and then also continue on the CAP. Carol and Paul, I already made you guys co-hosts, so you can share your screen for the slide deck that you linked.
Yeah, I just added them. So Pavel, the floor is yours today.
Okay. Let me okay. Can you see my presentation?
Yeah, I can share your presentation.
Okay, great. So unfortunately, I was not present on the previous meeting, but I know that there is like a lot of interest in our plans around workload aware scheduling and queue integration. So basically, I've prepared like short presentation to talk a bit how we think about this integration and what is like the rough plan right now, how we could progress or proceed with this integration. So on very high level, what we want to achieve with the WAS and queue integration is to have like a better alignment on core value provided by each component. With WAS, what we want to achieve is to make kubescheduler like a best solution for scheduling large workloads by starting with adding the awareness about the workloads and then adding options to optimize the scheduling decisions. And this is something which is happening for at least a couple of months already, and soon we'll reach another milestone with Kubernetes 1.37 release, where at least part of the APIs on the WAS side will be graduated to beta. With WAS, we want to focus on the scheduling part. So things like global queuing, quota enforcement, file sharing. This is not something that we aim to address with WAS, and this is a part of the workloads orchestration, which we see to be like a core value to be provided by Q. So this is the very high level split of responsibilities or the value, and by introducing it, we believe that we can solve one big problem which we have right now, where we have basically multiple scheduling engines which implement the similar logic operating on some scheduling constraints to calculate the placements for the workload. So by having this logic in one place, the core scheduling logic in WAS, we can make sure that the other components like Q will not need to basically do the same work to re-implement the same logic. And with new features, for instance, around workload aware scheduling or around the array, this is becoming even more relevant, because just to keep up with the upstream Kubernetes scheduling features for those alternative scheduler logic implementations becomes harder and harder. Similar problem, for instance, is faced by the Carpenter project, where the scheduling logic is also re-implemented, and supporting, for instance, the array is a major challenge. So how we want to basically allow different components to reuse this logic. So the solution which we started working on is the introduction of a scheduler library, which is basically a separate repo which builds on top of the upstream scheduler logic, and provides features to simulate the behavior of kube scheduler on some simulated cluster state. So just like a week or two, we have reached like a very first milestone with this architecture, where we got a first a very initial alpha version of the scheduler library to be released. This library was imported into Q, and we have the first integration which uses the scheduler library to check whether a given pod is or a part of given workload is schedulable at all on a given node, and this allows to reuse logic, for instance, for checking node selectors, tolerations, and a few other checks which the standard kube scheduler does when making the scheduling decisions. So this is something which was already done in Q 0.19, but this is very far from the target architecture which we aim for. So now I would like to talk a bit about how we see this integration to be extended in the future, with some very rough idea how this could be split between different Q versions. So in the next Q release, we would basically would like to extend the usage of scheduler library on the pod level. What we have right now in Q is just like very rough checks whether a pod can be scheduled on a given node, but it disregards like any other pods which might be running or which were admitted on a given node by Q. So in order to basically delegate things like resources checks to WAS, we need to extend the integration to make sure that the library will have the full picture of the cluster state as seen as Q. So it will have the information about the workloads which were admitted and which were scheduled by Q task implementation on a given workload, and based on this, we'll be able to not only check whether the pod basically matches the node properties, but we'll be able to check if the pod actually fits, taking into all the resources constraints. So I see some hands. Let me just finish with the slide, and I will try to answer any questions. So this is a part where we want to basically extend the scheduler library integration. The other part is the integration with WAS APIs. So Q already has like a feature where some groups of pods can be defined through some labels and annotations. We would like to provide like an alternative which would be based on the usage of WAS resources. This is quite important because without this, basically we can run into problems that Q will admit some subset of pods, but the scheduler will reject those because those do not fulfill WAS constraints. So I know that Kevin already created like a CAP proposal, basically going in this direction. Okay, so before I will move further, I see that there are some hands, so I can try to answer any questions.
Yeah, I mean, I did take a look at your slides and didn't see this, but like one thing that at least what we're working on in WAS is having the controllers themselves kind of define basically the scheduling constraints. And then like one of the hopes I have for Q is that Q should be reacting to like the controller API. Like for job, we have the job spec has like the scheduling stuff, and then that sort of should inform a lot of these things. I am not sure if this is covered in these two issues. I mean, I know that API standardization is we would read the workload in pod group, but I actually like my goal for like the job integration would be that there should be no workload or pod group until the job is created. So Q should really be reading the job spec and creating the basically creating the Q workload from these three objects, I guess. And that's sort of where like I'm not sure with these issues, like if these are tracked underneath there. And that's kind of like, I see Q has two, like we have true workload controller APIs, which we want to integrate with, and there's the pod integration, which I was looking at kind of separately for now because we still don't have controller integrations yet we have job, but we don't have any other ones yet. So that's at least another area that I know I'm looking at now, but I don't know if that's tracked here.
So for me, this definitely like falls in this API standardization category. So for me, like awareness of an additional like WAS related fields which we want to add to standard controllers is definitely in this like a group of tasks or caps. Which we would like to have as a part of this WAS Q integration effort. Yuki?
Can I take? Yeah, can I take? Yeah. So I have two questions. So the first is simulation engine. So as far as I know, schedule library has duplicated the codes with Kubernetes. Right? So framework library or whatever. In that case, so I'm worried about there are any different implementation across Kubernetes and schedule library. Is it same as today's Q and Kube scheduler code point? So will we resolve this duplicated code problem in the future? Any plan?
Is the question if we want to have like alternative implementations of scheduler library, or about like the plans for the library itself?
Yeah. So as far as I know, so to avoid importing Kubernetes to the schedule library, we just copy from the schedule some helpers and the framework code to the schedule library commentary. So my question is, will we resolve this duplicated copy and paste problem in the future or not?
Yeah. So I will talk a bit about this later on. So we are planning to have some changes on the library itself and on the core Kubernetes side. So we want to limit the scope of the code imported together with the library itself. Unfortunately, right now, the part which needs to be like imported has like the is placed in the Kubernetes root repo. But we are investigating to basically move like the large part of the core kube scheduler code into staging repo, which will allow to limit the scope of the code imported together with scheduler library. So we are aware of this issue, and there is some work around this on the kube scheduler side. We are not 100% sure if this if we'll be able to solve this in 138, but we definitely want at least try to address this problem.
So in the ideal world, in that case, in the ideal world, we will have some of helper and snapshot and cache library in the staging library, and the consolidated scheduling core mechanism will be hosted in schedule library repository. So helper and right, is it right?
Yeah, more or less, yes.
Okay, yeah. So can I ask one more question? So
yeah.
So about API standardization. So as Kevin mentioned, so currently job kube control manager only kube control manager job controller supports workload and pod group creation support. Yeah, in the future, yeah, we can support automatic creation in all native resource deployment, state of it, whatever. But so I'm wondering if, in case of custom controller hosted in-house mechanism or third-party open source project, so I just ask about if we migrated current queue annotation to the workload or pod group resource, so do we enforce to implement automatic workload and pod group creation in the third-party controllers if they want to use queue?
No. So like this proposal is to introduce the pod group resource like support as an alternative for the annotations and labels. So we don't want to like force those custom controllers to use it, but this with WAS being adopted by the standard controllers and new features being added to WAS, this will be encouraged. So we hope that the custom controllers will gradually migrate to this model, but when it comes to queue integration, we don't have plans to really enforce it in near future.
So in that case, I guess we will keep the current annotation mechanism as a limited support in the future, but we will support both mechanisms.
Yes.
Right.
Yes.
In that case, so how can we handle current queue pod and pod group integration? So should users manually create the workload and the pod group resource against the queue pod and the pod group integration?
So wait. So if I understand like the question correctly, there is no need to like change anything if the user is using like the labels and annotation. This will still work even with like the next milestones for the integration. We just want to avoid the situation where the controller basically integrates with WAS, starts creating pod groups composite pod groups and all the WAS resources. And Q is not aware of those. And basically, as I said, admits some subset of the pods only, and those will not be like bound to nodes by the scheduler due to pod group constraints. So we want to avoid the situation where custom controllers switch to WAS and without like adding queue specific labels, annotations on those workloads. Those workloads will break in an environment where both queue and WAS are present.
So does that mean so we will not duplicate the current annotation mechanism, and we will keep develop the additional functionality against both annotation mechanism and the WAS pod group?
Yes. I would encourage as a like WAS representative for the custom controllers to actually switch to WAS, but we don't want to like drop the current implementation in Q and the current feature and even in with the next steps, making the integration deeper, this still can be like fully supported.
I see. So we just
So just sorry, just like a 4-minute time check.
Sorry.
Yeah, continue.
So just a comment. So we, in that case, we just handle WAS pod group automatic creation mechanism as a strong recommended approach when external controller or pure pod integration are used in the production, right?
Yes, okay. Especially now when the WAS APIs will go to beta and they will be like the users will be able to enable those on some like regular clusters. We want to make the integration with those APIs recommended approach for custom controllers.
All right, sounds good. Thank you.
Kevin?
Yeah, I guess I know we talked a little bit offline on this one, but like there's a lot of work in flight here. I'm curious if we can have maybe something reoccurring on like the WAS Q integrations, or even if it's like we can maybe just async share some of the progress on like working group batch. I think that'd be helpful. I know there's a lot of things in flight. I'm interested in following a lot of this. I think not too sure exactly how to get organized here. I don't know if it should be in the workload aware scheduling meeting, or we could consider having like a separate weekly or bi-weekly call on this is one option we could do.
So in my opinion, like the more larger part of work will be on the Q side. So for me, like the batch working group is like a better forum to discuss this integration work, but we can discuss like having some dedicated forum for this.
Yeah, I mean, ideally, yes, but people are shared among both of those. So, like, I don't, like, I'm both a working group batch and a WAS person, so I don't necessarily care about the distinction. I just want to make sure we have the conversation with people that are interested. I don't, like, we can do it as working group batch. I just hope that we don't dominate other people's like features also, which is kind of everything's
so
anyway.
So we can, for instance, start with having like more frequent updates on the progress and planned work on the batch working group forum. And if this will start taking too much time of the meeting, we can discuss having like a dedicated meeting or forum. I don't know if this works with you.
Yeah, that's I think a big part we want is just more clarity on what's going on versus just, getting the PRs up. And yeah, I'm definitely interested in, I don't really care where it's going, so I'm interested in working this both in the WAS and the working group outside. So
I'll
just let
also
me
be in
know.
the WAS meetings. Yeah,
Yes.
so much cross-pollination. Okay, we're at time. Sorry for back. I don't think we're able to get to your item, but maybe you can also share in the working group batch channel. Otherwise, we can add it to the agenda for next time we meet. But yeah, otherwise, I'll see you all in 2 weeks. Yeah, thank you so much for your time and all the awesome presentations. All right, bye.